For nearly 60 years, a lost treasure has rested on the surface of the moon. The first human object to successfully land on the silver globe has remained elusive for decades. It is a true technological relic from the days of the hottest Cold War rivalry. Until now, an international team of scientists believes they are closer to finding it than ever before in history. We all remember perfectly well that the United States eventually won the space race on July 20th, 1969. American astronauts left their footprints there. But just 3 years before this event, the final outcome of the space race was not so certain at all. For a moment, the Soviets seemed to be confidently heading for victory. On February 3rd, 1966, Soviet engineers achieved a massive success. They performed a soft landing of the Luna 9 spacecraft on the moon. This probe was the first in history to transmit a photograph to Earth from the surface of another celestial body. Yet there is a mystery. Neil Armstrong and Buzz Aldrin left clear and perfectly documented footprints. In contrast, for decades, no one in the world knew the exact location of this Soviet probe. Let's think about that for a moment. We are talking about a giant milestone in human exploration of alien worlds. It is a priceless engineering artifact, and we simply lost this historic lander in the dust of the regolith. How is that even possible? In part, it stems from heavily outdated calculations of that era. But the key factor was the incredibly unique and daring landing method used for Luna 9. So, what did this famous historic soft landing look like? How did the Soviets approach it? Let's take a simple raw egg in our hand. Forgive me, but I don't have one here to show you. You will have to imagine it. Throwing an egg with all your might from a balcony onto a concrete sidewalk is a textbook example of a hard landing. It is also a waste of ingredients for a delicious batch of scrambled eggs. In a fraction of a second, the egg ceases to exist in its original form. It becomes a wet stain and a pile of crushed fragments. This is exactly how the first lunar probes ended their missions. They served simply as impactors. They strike the silver globe at a staggering speed of 1,000 kilometers per hour. They end up as shapeless heaps of metal. A soft landing is different. It is like dropping that same delicate egg onto a cushion. Cushion is so thick and flexible that the shell remains completely intact. Breakfast is still possible. In space engineering, this means the necessity of extremely precise braking of the ship's massive speed. The delicate optical and radio instruments must survive physical contact with the surface. The Americans in the Apollo program slowed down using complex rocket engine nozzles. They controlled them precisely until the very moment of touchdown, or rather moondown. The Soviet Union used a completely different concept for Luna 9. Before Luna 9 touched the surface, it ejected a spherical landing capsule. This capsule was shielded by special inflatable shock absorbers. In practice, it resembled an armored beach ball with electronics inside. Thanks to these gas bumpers, the equipment could safely bounce off the moon many times. It eventually came to a complete stop. This solution protected the instruments. However, the chaotic tumbling made it impossible to calculate the final resting place. Remember, the force of gravity on the moon is 6 times weaker than on Earth. These bounces and jumps occurred over much greater distances than they would on our planet. After the official conclusion of this epic mission, the Soviets published estimated coordinates. They were printed in a national newspaper. For years, this alleged location remained a subject of constant debate among astronomers. All researchers relied on archaic data. The situation gained momentum in 2009. That was when NASA's Lunar Reconnaissance Orbiter captured highly advanced images. The camera mercilessly exposed the truth. Luna 9 was not where it was supposed to be. Specialists realized the lost lander is likely many miles away from that region. Combing through vast stretches of lunar wasteland with the human eye is a task doomed to fail. Analyzing photos for an anomaly the size of a medicine ball is nearly impossible. We simply don't have that level of high resolution for the entire lunar surface. And this is where Lewis Pinnell steps in to continue the search. He is a data scientist from the prestigious University College London. He began designing a highly specialized machine learning algorithm. This is where AI comes to the rescue. Pinnell knew perfectly well that the computer needed a model to follow. He trained the system on high-quality images from the NASA orbiter. He used many well-known landing sites from the Apollo program era and taught his code to recognize American equipment. This way, it could find the Soviet hardware. The system was named, "You Only Look Once Extraterrestrial Artifact." If you look at the acronym, you get YOLO. Over time, the algorithm became very good. It identified even incredibly hard-to-spot tracks left by the landers. Let's explain how this machine learning actually works. Think about how we teach someone to recognize a specific car model. We don't make them memorize manuals with exact body angles. Instead, we show them hundreds of photos from different perspectives. The human brain picks out the details on its own. Machine learning is the digital version of that process. Researchers feed the computer thousands of images of lunar landing sites. The algorithm begins to instinctively understand the patterns. It sees how the exhaust from nozzles shapes the natural dust around the impact zone. It also understands how sunlight casts long, sharp, and geometric shadows. These are created by man-made components. They look different from the rounded, soft shadows of an ordinary crater. Team tested the YOLO system on images completely unknown to it. This included frames showing the Soviet Luna 16 lander from 1970. The results were stunning. The innovative program consistently displayed a high level of accuracy. Code worked more efficiently than expected. With a proven tool in hand, scientists assigned the algorithm its most important mission. They tasked it with scanning an area measuring approximately 4.9 by 4.9 kilometers. The computer returned with excellent news. It pointed to several locations with potential traces of artificial disturbances in the regolith. The researchers published their evidence in the journal Space Exploration. They believe they have narrowed down the list of search finalists. We have a short list of promising coordinates. We will not have to wait another 6 decades to confirm it. In March 2026, the Indian orbiter Chandrayaan flew directly over the selected area. This flyby was part of an ongoing project to map the lunar surface. It is worth explaining what this high-resolution mapping actually is. It is like paragliding just below the clouds over an endless and dense coniferous forest. From such a height, the vegetation blends into a single green blur. An ordinary camera will not show the details. But if we use a modern drone with powerful military-grade optics, everything changes. We stop seeing the big picture and start noticing the details. We see the crowns of individual pine trees and branches. With good sunlight, we even see the texture of the trunks in the clearings. Modern specialized orbiters like Chandrayaan are massive ships packed with technology. They are like great telescopes pointed downward instead of into deep space. During its maneuver, the orbiter pointed its lenses at the zone identified by the algorithm. It captured a crystal-clear view. Researchers can now physically compare the proposed landing sites with this new data. We will likely see our armored beach ball at last.